I'd like to add my welcome to, my name is Chris Gregg. I'm the director of the Master of Science in Sustainable Design program here at the School of Architecture. When we formulated the curriculum for the program, which is a 30 credit hour program, which we offer as a standalone degree as well as a joint degree with the Master of Architecture program, it was very clear to us that we needed to have a focus on materials, and so we included a course in sustainable materials and assemblies, and we advertised an interview, and we were fortunate then to appoint Brad Guy as the instructor, the professor, to teach that course. And he also offers electives in that program also. So it's my privilege to introduce the two speakers in this session, which gives us a practitioner's perspective. And our speakers are Lance Hosey and Russell Perring. And it's probably no surprise to anyone that they both work at William McDonough's practice, which, as most of us know, a pioneer of materials concerns. So as a brief introduction, we'll start off with Lance Hosey, who is the Chief Sustainability Officer with the global design leader RTKL, which is one of the world's largest architecture firms with 1,000 people in 12 offices in 3 continents, has significant reach and influence on the built environment. There are comprehensive bios in your handouts. I'm not going to read the whole thing, but I'm just going to read a few pertinent items. Lance's latest book, The Shape of Green, Architecture, Aesthetics, Ecology and Design, is the first book to study the relationship between sustainability and beauty, and has been Amazon's #1 bestseller for sustainable design. Sustainability leader John Elkington has called Lance an inspirational guide to a future we can't wait to embrace, and Builder magazine has said that he's on a crusade to revolutionize what it means to be sustainable. Lance's research and advocacy for material health has been published widely. Russell Perring is an architect with 36 years of experience and has, since 2005, co-led the sustainable design effort for Smith Group JJR. Prior to this tenure, he was the managing partner at William McDonough Partners from 1994 to 2005. He has been instrumental in encouraging 30 major design practices to write open letters to the industry asking for material disclosure. Under his leadership, Smith Group has joined with other firms in Washington, San Francisco, Phoenix, and Dallas to host public open dialogues with manufacturers on the need for transparency. As I mentioned earlier, Russ and Lance will give us a practitioner's perspective, and we'll start off with Russ, who will show the sort of how we got here, a historical perspective, and then tell us what's next. So.
Thank you. I fear that with this audience, I don't have a lot of new things to add. There's some people here who can certainly give a lot of this talk on their own. I wanted to start with a brief, and I'm going to go very fast, but a brief historical perspective on how we got here, because the majority of practitioners out there practicing today have entered the profession within the last 20 years, and that 20 years has been an interesting time of dialogue and exploration on materials. So I'm going to talk about how we got here, some of the things that have happened in the last couple of years which have been really accelerating the pace of change, and what is next. There are going to be lots of missing pieces in this history. Log them mentally for yourself. There just isn't time to really cover everything. But I like to say that in the beginning there was Building Green, Environmental Building News. They started their green spec in 1996. The U.S. Green Building Council was 3 years old, and they started in part to lead a conversation about products that avoid toxics and toxic materials and emissions. In '99 was the first lead pilot, and the limit of conversation about materiality in the pilot was about adhesives, sealants, and paints. The good news is that all of those industries jumped on it right away, and we saw a significant change in those industries quickly. The power of LEED was realized very soon after this. By 2001, there had been just a couple of other things in LEED dealing with materials. The Green Seal became the standard on paints and coatings, and we had standards raised for carpets and composite wood. And for the first time, we had a conversation about what ought not to be in materials, and urea formaldehyde won the prize as being the first of the red list materials to show up in this discussion. And it's good to see that conversation is still going on, and urea formaldehyde-free adhesives is still being explored through the EPA program, so that's good to see. In 2002, the Green Building Committee of the American Society of Healthcare Engineering came out with their guidance statement where they expanded the list of materials to be aware of and to be afraid of, in fact, to include mercury, arsenic, PVC, asbestos, in addition to urea formaldehyde. This became the Green Guide for Healthcare, really guided that, which came out in 2004, which focused on a number of persistent bioaccumulative toxins, PBTs, and started to suggest that the concern for these materials needed to be through the whole life cycle of the material. Cradle to Cradle came out as an assessment system in 2005. At that time, it was a proprietary assessment system to McDonough-Braungart Design Chemistry. It had 5 areas of concern. Material health was one of them. Pharos came out in 2006. Do I have that date correct? Is that right? And Pharos, as a tool of the Healthy Building Network, greatly expanded the publicly available assessment protocol. The Living Building Challenge also came out in 2006 and published its red list, which is incomplete, but was a starting point for all of us. That was now 8 years ago. Then there was the PVC review that came out of a lot of public conversation around LEED and should it be banning PVC. The interesting thing here is not necessarily what happened with PVC, but it was the realization through this committee that we needed an integrated method for material evaluation and that our LEED credits need to look at a more complete assessment. I would say, and Joel, you'll have to correct me if this is wrong, that LEED version 4's material attitude comes from this in many ways, from the PVC review and the suggestion there. Perkins & Will came out with their precautionary list, another version of a red list in 2009. Cradle to Cradle became a tool of the Cradle to Cradle Product Innovation Institute, also in 2009, and so you now it became an independent assessment tool. Green Screen came forward, and Green Screen you'll see referenced throughout these conversations as one of the major kind of assessment protocols, and it comes out of an EPA effort, the Design for Environment effort. Now, more recently, we've seen some exciting things happening in consumer goods. In 2013, Procter & Gamble announced plans to eliminate some specific chemicals, again, taking a free of attitude. Johnson & Johnson had done the same thing just before, and then Walmart followed in September of 2013 and suggested that there were a series of chemicals which they did not name that they were going to make they were going to insist that their suppliers make their products free of, taking a disclose all and avoid the worst approach. I think the most important thing that we can see from the action of Walmart is that they took a hazard approach, not a risk assessment approach. And this is something that I hope we have a little more time to spend on today, because this says if we believe something to be a known hazard, this is like a precautionary principle approach, let's don't use it, as opposed to saying, once we put it in the product, how much exposure is there going to be, and how much exposure, at what limit does this become hazardous, and to whom, and are they going to be exposed to it? It becomes a very complicated process that actually, in the description in the EPA website about risk assessment, it suggests it's more of an art than a science, and there are a lot of assumptions that go into a risk assessment. So hazard is the approach that Walmart took, and that's very interesting because the kind of red list approach that we see in the disclosure conversation derives from that. The Health Product Declaration, we've heard some of the history of that. I should say I'm on the board of Health Product Declaration Collaborative, and so I'm a big proponent of this approach. Launched in 2011, the pilot and then the V1 launched in 2012, and a third-party certification program launched at Greenville just this last November. Declare, which is the Living Building Challenges protocol for looking at materials, came out also in 2012. And now we have V4, and we have talked about V4 already today, but it does have the component of ingredient reporting followed by a component on optimization, both critical pieces under the MR Credit 4. Google Grant we have heard about. It's become a critical engine driving a lot of conversations, supporting a lot of these organizations, and has been taking what has been a very private attitude on the part of Google and making it more ubiquitous through the power of their support. One of the first things that was funded by the Google Grant was a harmonization effort. Lots of different players in this space, lots of overlapping concerns. How can all of these parties play together? What are the different roles? And a couple things came out of that. One was the urge for a comprehensive single portal of entry. We think that the Health Product Declaration is in many ways that, and a single repository for hazard classification data. Perhaps tools like the green screen become the right place for that. And that if we can agree on these kinds of fundamentals, that there can be all kinds of programs that come out of that looking for different kinds of things. And I think we are seeing that. Now, HKS, a major architectural practice originally in Dallas and now throughout the world, came out with a letter in December of 2000, what is that, Lance? 2012. That said, hey, this is to all the manufacturers in their database, we'd like to know what's in your stuff. Our clients expect us to know this. They have a right to know this, and we have a responsibility to find this out. If you want us to specify your products, you need to tell us what's in your stuff. We followed soon thereafter, as well as a number of other major practices. Lance's practice, more locally here, Air St. Gros has done this. And we have now a whole group of significant practices who sent out very similar letters saying, You got to tell us. Some people have said, if you don't tell us by a certain date, we're not going to have you in our library anymore, you can't come and give lunch and learns to our staff, and at a certain date, we're not going to use your products anymore. That's a pretty big stick and has been very effective at moving forward the move towards disclosure. So for the architects out there, there are opportunities here for you to continue this forward, and I'd be happy to give you blanks of the letter. Manufacturers have started to jump on board. Interestingly, Forbo sent out an email not too long ago, and then they gave links to firms that had asked for transparency. So it's getting to be a rather of a network on the web of these ideas. Building Green has sponsored a webinar. It's still posted on their site, saying, okay, now for architects, what the hell does this mean for your liability? Is this the tar baby in the clearing that you want to just skirt around and not get involved in? Once you touch it, you got it on you. Do you really want to be asking these questions, and what happens? And it's a very, very interesting question, and some of our colleagues have specifically not asked for disclosed ingredients because they don't want to get any on them. And we've got to break through this. That's something we definitely have to break through. The AIA has a working group put together. Melissa Wackerly from the AIA is here today. Marianne Lazarus and Paula McAvoy, HOK and Perkins and Will respectively, are chairing a group on materials to give guidance to the members of the AIA. We have, as was mentioned, had a series of forums, more than a dozen now in different cities around the country, to invite manufacturers into architectural practices and to get a conversation going. What is it that concerns you about this? What can we do to help? What are we going to do with the information? The one here locally was hosted by HDR and RTKL and Air St. Gross and ourselves. We are starting to be able to find HPDs in central locations on the web. There are those of you who subscribe to Green Wizard can find a listing of HPDs in their library. There is an HPD toolkit that was first developed at Pharos by HBN, is transitioning over to the Health Product Declaration Collaborative now. There are apparently a number of other aggregators who are going to put together lists of where you can find these materials, which is going to be an important thing for us. Now we're into the phase of training. And locally, or in our practice, the training, and for educators in the room, this is an important piece. There's a lot of alphabet soup out there, LCA, EPDs, PCRs, HPDs, et cetera. What the hell does this mean? Now, what we've seen here is a history that has been a common history for the majority of architects out there, and yet you go to most architects and you ask them what a product category rule is, for example, and they won't have a clue. We need to up the speed of uptake on this so that we can coherently work within what is now a more comprehensive multi-attribute kind of assessment of materials than was this single attribute. Is it recycled? Where did it come from? Does it have urea formaldehyde? Those kinds of questions that we had in the past. So there's a lot of training that we need to do. And then I think the big what's next is competition. When I look at where this disclosed information is going to have the most impact and who is going to use it, the first group to use it is the companies themselves. And they will use it, and we've already seen this, where a sales rep who has to deal with me goes back and says to the chemist who is working on their product development, why the hell do we have chemical X in our product. The architects are asking me, they're worried about this stuff, and they're looking for alternatives. And the chemist is saying things like, nobody ever asked before, why we have this. So this internal conversation within the companies who, in some cases, are saying, I don't want to go public telling people what's in my product because it's going to scare the hell out of them. And then someone else goes, well, why are we making products that scare the hell out of people? So that conversation within the companies, I think, really starts vigorously with disclosure. The second impact is across industries, where we have seen some industries are already starting to say, if we're going to be honest about what's in our stuff, we're going to have to be a lot more careful about it, and perhaps we should have our additional standards before these things become regulated, before we frighten all of the architects. Why don't we come up with our own standards and see if we can fix some of this internal chemistry? Then we have this whole group of people who are doing assessments. The cradle-to-cradle protocol is going to be made immensely easier once all the materials are disclosed. Then we have rating systems that will be using this information to help to classify buildings as to whether they are green or better. You'll have journalists who will begin to interpret this information for us, so we'll get articles in Building Green that'll say, if you're looking at office furniture, take this into account, take that into account. Way down the list here are the designers themselves. Now, this is somewhat counterintuitive because we're the ones asking for this information, but we're asking for this information because of all these other groups who can make use of this disclosure. I do not have any industrial hygienists on my staff. The number of people who can tell the difference between bisphenol A and bisphenol S, it's limited to maybe a handful, if I'm lucky. So the actual chemistry is not a key component of what we do as architects. But I would say that the rest of this list of people who are going to make use of this information is going to make our work better. And I'd say what's also next is we have momentum, the really good story from ThyssenKrupp. They came back to the Health Product Declaration Collaborative and said, well, we make elevators. Our standard product has 10,000 components. So I guess we got to do HPDs on 10,000 components. Here's the first one, and we're going to go from there. So it is starting to move. So that was my quick romp through where we've been and where we are today. Thanks.
Hi, everybody. I'm Lance Hosey. I'm the Chief Sustainability Officer with RTKL. As Russ mentioned earlier, coming to an event like this often feels like preaching to the choir. So one of the things that he and I have often talked about is how to use firms like ours, which are two of the largest firms in the world, to create more leverage, to spur more momentum, but also create a bigger dialogue. Now, one of the things that we can do, and this is the perspective I'm bringing to you today, is just how to wrestle with this in practice, is my firm has 1,000 people. We are owned by a 22,000 person parent company, so that's a pretty large audience to grapple with this, who has to listen to us when we send out an email. Sometimes they may not open the email. So some of what I'm going to share with you today is just how we get that dialogue internally in order to create a better outward-facing dialogue. So we have 12 or 13 offices with 1,000 people in 4 continents, and I think we're currently the 5th or 6th largest architecture firm in the world. We work on every scale and every type of project around the world. So the reason I took this job is the expression, give me a lever long enough, I can move the world. This is a very long lever. Now, one of RTKL's, part of its vision statement is to build a better world. And big part of that today is the emerging dialogue around material health, which we're here to talk about today. Now, I want to point out that just to give you an idea of how tough this is to grapple with in a 70-year-old, 1,000-person corporate firm. Until I joined a year and a half ago, there was no one focused on sustainability at RTKL. There are lots of people doing it on an ad hoc basis, very smart people, very knowledgeable about this, but there was no strategic focus on it. Now, within the last year and a half, our team has grown a little bit, and the core team is all here today to give you an idea of how big it is. So Heather and Tanya, could you guys stand up? Heather Nelson over here joined last summer from University of Oregon, and Tanya Mejia there we stole from the USGBC about 3 weeks ago. So that is the team out of 1,000 people. We hope by the end of the year, or maybe within half a decade, we'll take over the universe. But that's it. We're all here. Now, I put up this slide originally because I wanted an opportunity to say out loud the best book title ever, Slow Death by Rubber Duck. But it turns out after listening to the other presenters that there are other reasons to put this up. First reason is that now when you talk about environmental toxicity, you might think of Silent Spring, large global problems such as DDT, or Erin Brockovich, you think of, or Love Canal, it's big toxic spills, companies putting terrible things into rivers. But there's more and more evidence that the bigger threat is actually the toxic chemicals that are in everyday products that you give to your babies. Now, a lot of those are in buildings. So some of the stats here, I thought by the time we got to me, you would have heard many times over already. But just to give you the big picture, we spend virtually all of our time indoors, and the EPA has rated indoor air pollution as one of the top 5 environmental risks to public health. And a big part of that is the materials and products we use to create spaces like this. You cannot call yourself a responsible architect today and not grapple with this issue. And here's why, because we know too much about how little we know. Say that again, we know too much about how little we know. As Russ told you, just understanding how much there is to understand is the tip of the iceberg around this issue. So with a 1,000-person, 5th or 6th largest architecture firm in the world, we feel that we're not doing our jobs unless we're grappling with this. So let me give you an idea of one of the ways we're grappling with this, just to give people at RTKL a baseline knowledge around some of these issues. This is something that Heather has worked tirelessly on over the last 9 months or so. It's what we call our performance-driven design toolbox. PDD is our sort of branded strategy for sustainability. We've identified 12 priority topics around the classic triple bottom line, and we've organized this around 18 strategies that can lead to those different kinds of values. We've helped people at RTKL understand at what point in a project each of these strategies or values come into play and provide the most value. But then we have this matrix that shows if you're interested, say, in cost of construction, you can zero in on those strategies that can help. If you're interested in climate issues, you can zero in on those strategies. And if you're interested in health and well-being, you can get quickly to those strategies that can help. A big one of those is material health. So here's our sort of Cliff's Notes, a 101 overview of what material health is, why it's important, how to do it. We've organized it around 3 big topics. How do you choose safer materials? Some of the lists you've heard about today are there. How do you review chemicals of concern? How do you encourage more transparency? And that's all of what Russ talked about. Here's our letter that Russ mentioned, urging manufacturers to provide more transparency, signed by the 2 Lances. I report to our CEOs, Lance Josel. And then finally, we have this value impact rating. As I said to Heather over the weekend as I was preparing this, I think the value impact of the material health is bigger than we indicate here. And then we have some case studies both from our own work and other people's work. To give you an idea of the state of the market, this is one of our bigger, better known public projects. It's the Visitor Center for the US Capitol. And it's considered one of our leading edge projects around material health because it had a rigorous protocol to remove VOC emitting materials, but that's it. Now, and one of the stats we hear often about this project is the material assessment protocol coupled with the air changes in the mechanical system lead this project to having air quality that's better than the top of the Rocky Mountains. But That's it. It was limited to just VOC, so you get an idea of how difficult this is to grapple with in big projects. So to give you another sense of that, I'll use a case study from my days at McDonough. I left there in 2009. I was there about a decade. Russ and I overlapped about half that time. And one of the last projects I was involved in was a collaboration with Anshin and Allen for the largest project in University of California history, the UCSF Medical Center at Mission Bay. If you fly into SFO and drive into downtown San Francisco, it's that huge construction project on your right off the freeway. So I'll try to quickly go through this. For a big hospital in a teaching university, obviously health was an important issue, which sounds like common sense, but you'd be shocked at the number of healthcare design projects that don't put health front and center. So now there are a number of different strategies we were using to promote health, including all the latest research around connection to the outdoors, daylight, fresh air views, et cetera. And a priority one was what I'm putting here is, quote, choose healthy materials. Remember that because I'll come back to it in a minute. And this was this little sort of value impact matrix. What are the different kinds of things we're trying to do in the design? How do these different strategies impact that? And we identified, quote unquote, healthy materials as one of the top 2 strategies. This gives you an idea. Now, note that using a different phrase here is safe materials. Again, I'll come back to that distinction a little later. And this gives you a sense of the value that can create, which is pretty much across the board, as much value as possible. Those last 2 things, how does this compare to the LEED rating system? And how does it compare to other leading green hospitals? This client was very interested in distinguishing themselves in the market, so we did a very close analysis of LEED and Green Guide for Healthcare, at least the state of LEED at that time, which was 2007, 2008. And for each of the credits, each of the topics in these rating systems, we identified a spectrum of quality from market standard to what we imagined would be 100% good. If you know anything about Bill McDonough, that's one of his favorite phrases. What is 100% good? And we thought that with most of these strategies, but particularly around safe materials, that these rating systems essentially, at least at that time, were targeting about halfway between market standard and what's really possible. LEED version 4, one of the most significant changes is much more rigorous credits around materials and resources. We did the same thing with these 5 case studies of what at the time we thought were the leading green hospitals that were either being built or had just been built. And you can see here that safe materials was very low on their list of priorities. A lot of hospitals are focusing on things like energy because there's so many costs involved. So now, when it comes to this, as Ashley gave you a sense earlier, how complicated is this? If you said that you wanted to make a building out of all of the state-of-the-art materials available today, that even if your only focus was to remove all the chemicals of concern, you couldn't do it. For a large, complex project like this hospital, there just aren't enough products available on the market. And something like this, which was a state-funded project, because it's a government-sponsored project, for every material or product we specified, there had to be at least 2 other alternatives, right? So imagine the thousands, many thousands of materials that go into a big hospital and then multiply that by 3, there's just no way you could make every product meaningful. So we had to focus, where are our priorities? This is an image from Stuart Brand's How Buildings Learn, and you get a sense of the time scale of different components in a building. The site is considered to be eternal because the Earth never goes away, as far as we know, unless there's a giant asteroid or something. The other end of the spectrum is furniture like this could be here for a day. And then there are a variety of different components in between. Now, if you think about something like structure, which is going to last conceivably as long as the building will, you'd think, well, it's important to get that right in the first iteration because you won't have much chance to change it in the future. But often structure is buried underneath other kinds of materials, so it's not necessarily exposed to your breathing space. Whereas the finishes, which do change out every handful of years or so, paint and drywall and other things, are right here in your breathing space, and you rub up against them. So what we decided is we'd focus in this hospital exclusively on the finishes in the patient and staff areas. The thought being that, look, we can't take on everything. What can we take on? We'll be as rigorous as possible around just those areas. For every strategy in this hospital, including safe materials, we'd identified 4 different categories of quality, and we suggested that the highest category would be to assess every material coming into the building with the most rigorous protocols. We couldn't do that, so this was what we decided would be level 3. Here's an idea of the different kinds of things we were looking at, and here's how we went about it. So we put together this sort of proto-HPD. McDonough's practice going back 10 or 15 years had developed various versions of what at the time we were calling a supply chain tool, which is essentially a super MSDS that you give to manufacturers just to see what's in their stuff. As you've heard, usually there were 3 responses. One is, we don't have to give you that information, it's proprietary, go away. The second is that, oh sure, we're happy to help, here's what's in our stuff. The third, which I think is the most common, is we'd love to help, but we don't know what's in our stuff. Because we buy it from other people who buy it from other people, and it's all sort of nested in what you buy from us. So the bigger challenges, even the people you're talking to, are just the tip of the iceberg of the whole supply chain. So we put together what at the time we imagined was a more rigorous version of this, and then we organized them into these 3 categories. No, we'd never use that. Yes, we definitely use that, or we don't know, we need to look at it more closely. So we work very closely with MBDC, whom you heard about from Russ, and they have a variety of different things they look at with human health. Now, what they do, and this is not necessarily very well known to the public, is they tend to weight these different categories depending on the application. In this case, human health took priority over other issues. So if we thought a product it fared very well in that, it raced to the top of the list. Now, here's the thing that I want to share with you. This is a diagram that has made the rounds for this case study in this project, this sort of meat grinder of materials, we were calling it, that of all the different things we looked at, all the questionnaires we sent out, all the available materials, by going through this rigorous assessment protocol, we identified fewer than 10% of the available materials would even be considered for this project, just to give you an idea of how little is out there that might actually pass muster. This is one of the case studies in the 2nd edition of Gail Vittori and Robin Gunther's Sustainable Healthcare Architecture, which, if you haven't seen, is brilliant around these topics. And then finally, what I want to close with is, I mentioned before, language. Ashley gave you a sense of how important language is. Sometimes we have a dialogue around about this. We use words like sustainable to mean different things, so you have a disconnect without quite realizing it, because it ends up being a shorthand for a variety of different things. One of those words is healthy. We use the word healthy, but this is halfway through this event, and no one has defined the term yet. Have you noticed that? So, here's the thing, you see this phrase, you saw it in my presentation just now. We began the project with the phrase healthy materials and ended the project with safe or safer materials, because we realized along the way we weren't comfortable with this phrase, but you see it a lot. You've seen it here today. Google has a healthy materials program. There are lots of people who throw this word out. But here's the question, what is health? So I wrote an article, and I have a regular series in the Huffington Post, and last year I wrote an article about this, and one of the people I interviewed was John Warner, who is the co-author of Green Chemistry, which you heard about earlier. And John says, health is simply the absence of sickness. Well, the World Health Organization actually says that health is a state of complete well-being and not merely the absence of sickness. So which is it we're talking about? When we talk about promoting health, does it mean that we're trying to take all the harmful stuff out of materials? Or are we trying to use materials that actually promote health in the sense of this larger state of well-being? So here's the article. I argued that we should never use the phrase healthy materials because it's misleading. You may know that in the last several months, Pepsi lost a lawsuit for using the word natural in some of its beverages, and now they have to go around and remove them. So it's important the signals we're sending. Is something healthy simply because it doesn't have formaldehyde in it? Or is it just not as dangerous as it would have been if it did have formaldehyde. Now what's interesting is Heather, I mentioned here, she responded to this brilliantly in her own blog. I didn't know you were going to be here, so I'm sorry if I'm embarrassing you. This idea that, well, what if we could actually make healthy materials in the sense that they would promote a more positive state of well-being? So she looked at, and you can throw something at me if I get this wrong since I'm speaking on your behalf. So she looked at, all right, for instance, there are textiles out there, t-shirts that are embedded with vitamin C, and your skin starts to absorb them. And does that really work? Is it actually helping? So she looked at the science of how we absorb things in our skin, and it requires heat to turn something into a liquid form, right? And by and large, that's not happening when I rub up against this dais, right? So no matter what's in here, it's probably not likely that I'm going to absorb it in my skin. For those of you who are chemists or scientists in the room, if I've gotten the science wrong, feel free to correct me. But some of the questions she raised were, for instance, there have been lots of questions about aluminum over the years about what its health impact is, and there's aluminum all over environments like this. It's in handrails and door pulls and pushes. So the body craves minerals such as magnesium. So Heather was asking, well, what if we replaced aluminum with something like magnesium that the body actually craves? Could we actually say that we're tipping over from less bad to more good? The jury is still out on that. I don't know whether that will happen, but to my knowledge, there's been a lot of research showing that environments can be healthier in the sense that we're describing. Lots of research showing that in hospitals, for instance, if you have connection to the outdoors and more daylight and fresh air, it'll speed up patient recovery rates, mostly by making the indoor environment a little more like the outdoor environment. So the thought is that all those kinds of strategies can reduce stress, promote health, etc. To my knowledge, there's never ever been any study showing that benign materials, meaning materials that have all these toxic chemicals removed from them, actually promote better health. They may avoid sickness, but to my knowledge, there's never been a study saying it actually has a positive impact. Now, when we were working on this UCSF project, what I suggested to the client is, it's going to take years to develop. That was 7 years ago, and it's not even done yet. They have a hospital already. Why don't you use this as an experiment? Replace finishes in half your patient rooms with all the state-of-the-art materials you can find, and just see if there's any discernible impact. They didn't end up doing it. I don't know that anyone has done it. If there's anyone in the room who has any influence on these kinds of things, from my perspective, that's a huge gap in the research that could be really valuable. Thank you.
Great, thanks very much. I think we've broken the barrier onto the optimism scale now. I get that impression, especially from what Lance said in the latter part of his presentation. My sort of phrase for Lance is architect provocteur, and I'm glad now that he's encouraging 2 more architect provocateurs.
I can't even say that.
We don't have much time for Q&A, and so before sort of launching into some of the questions that I might have, I just wonder whether anyone in the audience has any comments or questions for the 2 presenters. No any issues? Yes, please.
Where is durability the issue?
Where is the durability issue?
Yes.
It's everywhere, obviously. The Lance's diagram from Stuart Brand dives into the durability question, I think, by saying those things that are going to be in the building the longest ought to be the most durable. I think that's kind of an obvious thing, and it actually does beg the question, what the hell is vinyl wall covering about? It's only going to be in the building a couple of years. Why do you make it out of something that once we put it in the landfill will be there forever? I mean, that's a sort of an overuse of durability. I think it needs to be balanced to the materiality.
Yeah, I would just add that I meant to say this, and someone should say it, that materials are, they are the stuff, they're the equivalent of the ingredients in food, right? There is no food without the ingredients. There is no building without materials. And there are any number of complex issues that are important, durability being one of them. My impression is that durability is one of the well-established criteria that designers and architects use when choosing materials. I think what we're here to talk about today are what are some of those criteria that haven't been terribly important in material selection. Health is one of them. One of the ones that I've written about and spoken a lot about is social equity around material choices. It's something that has gotten almost no attention whatsoever. So there are any number of topics we could grapple with, but we're just talking about one today. I think Russ mentioned earlier that we're still at the point where we're looking at these issues in isolation, but how do we get to the point where we see the interconnectedness between them all?
Was any other questions from the floor? Yes, please.
I'm Kathy Broad. I'm with USDA, and I apologize for having to join you all an hour late. I am interested in life cycle assessment and the evaluation of how does each material stack up vis-a-vis its effect on what we rely on, like the atmosphere and greenhouse gas emissions and things like that. And I'm wondering what your thoughts are on that, Lance in particular, and everyone. But there are, for instance, we've got a study. Okay, so USDA did a study a couple of years back at the Forest Products Research Lab, which concluded that many wood products are more environmentally sustainable because their say carbon footprint or their effect on how much embodied energy they have is comparatively better than steel or concrete. I was a little cynical of this because it's kind of an industry-driven thing as well. But the truth is there are some that stack up better in terms of their manufacturing processes or delivery, to a site, etc. So I know it's a big question, but there's always a balancing act in terms of what are we providing for human health, what are we providing for our long-term health as a society and as a world.
Yeah, I think it's the same question, right? So if you look at something around one topic, it might fare really well. When you look at it in another topic and it looks like you might as well build a building out of plutonium, right? This is one of the things that LEED has been grappling with, and I think the evolution of LEED shows how complex this is. I mean, a decade ago, one of the things that, apologies to anybody from the USGBC here, that I made fun of was, so on one hand, if you source a material locally, it doesn't matter what it is. It could be solid plutonium, and as long as you got it from within 500 miles, it worked. Another credit was rapidly renewable materials, and one of the most popular ones is bamboo, and it all comes from China, which is nowhere near here, right? So, disconnect. Russ mentioned vinyl. I mean, the way that vinyl is typically touted is, it's all recycled material, right? It's easily recyclable. It's very durable, right? But then if you look at it from a health standpoint, it's just disastrous. Sorry, vinyl people.
Yes.
So I've got a question that I'm hoping will tie into what the next panel will be discussing, which is, there's obviously a lot of relatively new topics that we're expecting architects to understand and be trained in. And I'm wondering, is this something that you as practitioners would hope that in the future, when you hire a student, do their internship and everything, would you hope that they come to your organization already knowing all of these issues, or do you see this as more the architecture firm should be training someone once they join your organization?
What a great question. I would say that in the 20 years that I've been dealing with the issues of sustainability and sustainable design, in practice, we have not yet seen the time when new grads consistently come to us with information that is particularly useful when it comes to sustainability. Now, this is
about anything?
However, many of them do come with attitudes and worldviews that are very, very useful and helpful, and a willingness to learn. Some do come with lead AP already, and that's a great thing. It is changing, and I think we are getting better informed students now than we were several years ago. I would like to see new grads come to us with an understanding for the complexity of all of this, for how do you balance these things, like all of the pieces that go into an LCA, which includes the transportation from long distances away, that includes the pesticides used in the growing of bamboo, etc. I would like to see the students come with an understanding for that complexity. I would love to see them come with a fundamental chemistry background. I haven't seen it yet.
Yeah, it's a really great question. So about, I don't know, 5, 6, 7 years ago, Kira Gould and I co-authored a report for the AIA on the state of sustainability education in architecture schools. What we found by and large is there are a lot of schools with interesting one-off courses or initiatives or minor elective programs, and at the time, to my knowledge still, there's not a single school of architecture that's committed to ensuring that every student who walks in and out of the doors is steeped in these principles. The state of the curriculum has not transformed to take this on. It's a growing topic. Ed Masria authored a letter to NAB last year that I think all of our firms signed, urging them to grapple with this more. Until that happens, until it's embedded in the curriculum, then it's just going to fall through the cracks, right? Because you're relying on ad hoc interest at a grassroots level rather than a strategic top-down level. Now, the analogy is to firms like ours that, you know, when I joined just a year and a half ago, there were lots of people doing really, really interesting things, great projects, but it was sort of, it wasn't connected. And with 1,000 people, if someone in Shanghai does something brilliant and nobody in Miami learns about it, then Shanghai's getting smarter and Miami isn't. So you're operating like a bunch of small firms rather than taking advantage of your size to create a larger knowledge base. So I showed you the toolbox earlier. That's our sort of 101 level. If you've never had any exposure to sustainable design, here's the quick sort of sustainable design for dummies. Organized around the topics that we think are most relevant to our practice, filtered through a lens that we think is relevant to our practitioners. Now, other ways that we're looking at doing this strategically is the other person from RTL here is Allison Price, is sitting up there, who, outside of our team, because she's the only person here, we have now anointed as the person who's going to become the material health expert at RTL, just because you stumbled in here stupidly one day. So, for instance, everybody at every firm like this has a certain amount of time they put into continuing education every year. They have to do it to keep their AIA membership, etc. But usually the way it happens is, well, that looks interesting, and it doesn't add up to anything larger. So we've taken all the topics in this toolbox and identified this as priority knowledge areas, and we're looking for a certain number of people to become experts over a 2-year period by applying their continuing ed to those topics. So Allison might become very smart about this issue, but she may not be an energy expert, which is fine, because then if you know, well, I'm interested in material health, I'm going to go talk to her.
I'd like to think that through our sustainable design program, we are addressing some of these issues. That's my plug, but thanks, Tracy, for asking that question. I think it leads us smoothly into the next session. And so I think another short break.
Yeah, we're gonna just 5-minute break, and then we're gonna come back, and that is the perfect segue.
Okay. Thank you very much, Dr. Dennis.